In this video, I'm going to talk about trigonometric identities, or just trig identities. These are various forms of equal expressions. So you might be familiar with this first one. Sine is equal to the reciprocal of cosecant. So cosecant and sine are reciprocals of each other. And so if you know that your sine ratio of an angle, if you flip that ratio, you get the cosecant ratio. So it could also be said that cosecant would be equal to 1 over sine. So these are known as reciprocal identities. Each side of this equation are equal values. And they're just reciprocals of each other. You might also be familiar with the reciprocal of cosine being secant. So 1 over secant would be cosine. And the same would be true if we flipped it. Secant would be the same as the reciprocal of cosine, or 1 over cosine. And our last one, tangent is the reciprocal of cotangent. So tangent is equal to 1 over cotangent. And cotangent is the reciprocal of tangent. So 1 over tangent is cotangent. So these are the 6 basic reciprocal identities. It's important to know that the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So become familiar with those identities. We have a couple more here. They're called quotient identities because we set up a ratio or two things being divided. You may know that tangent is the ratio of y over x. Well, if we apply that to trigonometry, we know that a y value is a sine value, or sine of an angle, and an x coordinate is cosine of an angle. So tangent is also equal to the ratio of sine over cosine. And we could say the same thing about cotangent, since we know that cotangent is the reciprocal of tangent. Then we would flip our ratio. Cotangent would be x over y, and that would be cosine of an angle over sine of an angle. And we could also play around with these just a little bit more here. If we think about our reciprocals, the reciprocal of sine is 1 over cosecant. And the reciprocal of cosine is 1 over secant. And now if I divide my two fractions, flip and multiply, I end up doing this multiplication. And so what I end up getting is secant over cosecant of an angle. So tangent could also be written as secant over cosecant. That is not seen as much as sine over cosine, but it is still true. And we could do the same thing, but in terms of cotangent here. And so cotangent would end up being the reciprocal of that. So cotangent could also be cosecant on top this time over secant of an angle on the bottom. So tangent could be secant over cosecant. Cotangent could also be cosecant over secant. But usually you're going to see these quotient identities a little bit more, and you'll probably use them a little bit more than these. Alright, so those are your quotient identities. The last set of identities for part 1 here are going to be called Pythagorean identities, and these are kind of the trickiest ones. If you think back to the Pythagorean theorem, you know it as a squared plus b squared equals c squared. Well, in pre-calculus and trigonometry, we begin to look at these variables slightly differently. We say x squared plus y squared equals r squared. And then if we think about these variables in terms of more trigonometry, we know that x values are cosine of an angle values. And since it's x squared, we would say it's cosine squared. Do the same thing with our y. Y values are sine of an angle values. And since it's y squared, it's going to be sine squared. And if we're dealing in trigonometry on a unit circle, the radius of our unit circle is always equal to 1. So we could say that r is 1, and we could say r squared is 1 squared, which just turns out to be 1. So we just rewrote our Pythagorean theorem in terms of trigonometry, and we get this expression, or this equation: cosine squared plus sine squared equals 1. And that will always be true. Now the tricky part comes when you have to identify this in a different form. So if we solve for each of these terms, we get a slightly different variation or different identity of this equation here. So if I want to solve for sine squared, I would subtract cosine squared from both sides. And so I could then write it in terms of sine squared. Sine squared would be 1 minus cosine squared. Sorry. You can use an angle symbol, a theta symbol. You could use x. I mean the variable that represents the angle right here could be written in a variety of ways. So it could be x, it could be a smiley face, it could be really anything. But theta is often used to represent an angle measurement. And x is another one that's often used in this spot as well. So sine squared of an angle is equal to 1 minus cosine squared of an angle. If we do the same thing and we solve in terms for cosine squared, we would be subtracting sine squared from both sides. And so we could write it in terms of cosine squared. Cosine squared would be equal to 1 minus sine squared. So there's a different form of our Pythagorean identity. We could also take it even farther, and we could solve for just sine, and we could have a different identity for sine again. So way back up at the top, we talked about how sine is a y value, a y coordinate. It's also 1 over cosecant, but it's also can be viewed as a different form. If we square root both sides, then we get sine is also equal to the square root of 1 minus cosine squared. So we're just taking this form right here and square rooting both sides. So now we have another identity for sine. And we could do the same thing for cosine. If I square root both sides at this step, I have another identity for cosine, which is, oops, we square root both sides. The square root of 1 minus sine squared, under a radical this time. So there's another identity for cosine, square root of 1 minus sine squared. So the Pythagorean identities are kind of a lot, and it's a little tricky to identify them unless you've practiced them a lot. So make sure you practice these identities. It helps to learn them.